One problem with increasing population and advancing industrialization is high volume of waste generation. The Environmental Management Bureau of the Departments of Environment and Natural Resources releases an annual report on the Philippines' solid waste management status. From its 2015 report, it is projected that from 14.66 million metric tons of waste generated in 2014, the country will produce 20.5 million metric tons of solid wastes by the year 2030. Additional quantification from the Senate Economic Planning Office further reports that the country's daily waste generation from 37,427.46 tons per day in 2012 steadily increased to 40,087.45 tons in 2016. From this data, the country will yield a 165% increase to 77,776 tons of accumulated daily waste by 2025. The figures are expected to fluctuate significantly as the surge of COVID-induced wastes become more prominent due to food delivery and online shopping. This issue accompanies challenges in logistics, environmental impact, and health effects. Hence, waste management is a very important issue that needs to be addressed. In the past, there was a wide use of incinerators to minimize waste. However, incineration produces high volumes of flue gas which heavily affects the environment. This concern was properly administered by the ratified RA 8749, otherwise known as the Philippine Clean Air Act of 1999. Comprehensive air quality management policy and program. This law was legally ordered to abolish the practice of incineration. Based on the waste management hierarchy, after prevention, minimization, reuse, and recycling are done, solid wastes are to be subjected first to energy recovery before disposal. This is a beneficial way to recover wastes into functional and value products or goods.
Which is why this project is conducted to utilize both municipal solid waste and agricultural biomass in order to manage waste disposal while providing energy for rural communities. I am Alexander Mosqueda, the project leader for the research, key technological research of Philippines and China on portable power generation based on gasification of municipal solid waste and agricultural biomass pre-treated by co-hydrothermal process. By investigating the effect of biomass and municipal solid waste composition on the energy yield, this project aims to produce high-value products to be used as a fuel. The project utilizes lignocellulosic biomass as important carbon-containing components of the mixture. The Philippines is an agricultural country that produces large quantities of crops. These agricultural crops leave large amounts of agricultural biomass upon harvest. These wastes are usually left to decompose, leaving its energy content unutilized. Meanwhile, municipal solid waste is a mixture of organic, paper, and plastic-based waste that vary in composition. Its makeup is largely dependent on the source of the waste, such that rural communities have more organic-based waste and urban communities lean more in plastic-based. Despite its non-uniform composition, municipal solid waste has decent carbon content, which can be improved to be used as fuel. Critical factors that need keen concern upon dealing with a mixture of municipal solid waste and biomass is its inhomogeneity in composition and size, and high moisture content. Agricultural biomass has different amounts of cellulose, hemicellulose, lignin, and others. Likewise, municipal solid waste has no definite composition when acquired by the LGUs. Moisture content, which is highly definitive of the energy content, is known to be elevated in agricultural biomass. Simply put, moisture content is inversely proportional to its energy yield. This can be overcome by treating municipal solid waste and biomass mixture hydrothermally to yield a coal-like end product called hydrochar, a clean, dry, and homogenized solid fuel. The hydrochar is then further processed for gasification, another technological action to convert it to syngas for power generation. The process of hydrothermal treatment of municipal solid waste and biomass and subsequent gasification will govern the pilot generating plant that shall be built as the end product of this project. Furthermore, the plant is designed to be modular in nature to provide portable energy conversion, especially in most remote areas where modernization is not yet reached, while harnessing this community's own solid and agricultural waste. This is a 2-year project funded by PCIEERD under the DOST, Ministry of Science and Technology of China, Joint Research Program.